So I'm going to present the screen. There we go. And let's see. ECM video analysis. I thought the videos were pretty cool, actually.
Okay.
Yeah.
When is my course start?
That's that one guy in the
That was very challenging.
Hey,
I got this easy, guys.
it makes no sense. It says you can enroll in one or more courses that haven't started yet. And it doesn't tell you when it starts. Because I didn't write it down.
Okay,
So.
I'm going to be showing the videos. I'm going to be showing out how to work them out. Then we'll see how we're feeling after that. Sound like a plan?
Sounds like a play.
Let's rock and roll. Okay, so the first video.
Okay,
Yes.
when I'm on Cami and I try and like write stuff with like a little pen thingy, I just can't write.
Can we like just, is it Cammy or Tommy?
It's like
I say
use
Cami.
the mouse to try and help, but it's not helping.
Cammy, okay. Every one of my teachers last year said Tommy.
Kami sounds like when people say crayons or caramel.
No, Kami sounds like short for
It's crayons and caramel.
Kami is short for communist and nothing else.
All right, so we're going to watch the video real quick, just to review.
I know it's wrong, but it's
All right.
best, baby. God's blessing it.
Right, the guy tries to run the circle.
This was cool.
Yeah.
I liked this.
It was pretty cool.
When I say that I was so far off of the answer, and I have no idea.
Okay. Oh, so this guy's genius. Yeah, he's not that smart, but he's very athletic. I'll give him that.
No, I was pretty close on this.
I mean, here's the
I got
thing.
8.
He's not wearing a helmet, and he is face planting in the ground many times.
This is
Like, you just have to commit.
Yeah.
Get on a helmet.
I don't even have one like that.
Like, when you're at the top and your head is upside down, I would not move my legs. I would freeze. Like, he had to keep moving his legs to keep going around, but I would just stop. Like, I don't know. I would
have face.
I want to try it, but
There's no way that's a live reaction. There's no way people sat around and watched him face plant.
Okay, so at this point, right here probably would have been the best one to measure the circle. All right, so it says using a ruler. I'm just on problem 1, number 1. Problem 1, number 1. Okay. I guess what I can do is, let me pull this guy up. Problem 1, number 1 says, using a ruler, find a spot on the video which will help you make a good estimate of what the radius of the loop is. So I got in meters the radius to be around 1.5 meters.
That's what I know.
Yeah, something close to that. You might have got 1.2 to 1.8 somewhere in there. Since his height was 1.8, hopefully you said anything less than 1.8 because he was over halfway tall, over halfway. Okay. You have to see that all right. Let me zoom in. Kind of hard to see. That's better. Okay, so I got 1.5 for number 1. Number 2 says, draw a free body diagram of Damian Walter at the top and bottom of the loop. If he goes through the loop with a minimum amount of speed necessary. Okay, so we have the loop-de-loop. Okay, so let's do the bottom first. At the very bottom, there's 2 forces acting on the very bottom. One is force normal, or one is force gravity. Well, no, second one's force normal. Okay, it's kind of hard to read. I don't like my pencil. We're going 10. We're switching it up. Okay.
hopefully you don't find another cow in there. I was kidding.
He found an actual bird in his classroom.
Yeah, he-
he doesn't like.
Did you clean up that bird scoop then?
I did, yeah.
All right, thank you. All right, the second one, so at the very top, if he's going the very minimum, there's not going to be force normal. There's only going to be one forcing acting on it. So there's only the force
Yes
of
on
gravity.
that. Let's go.
I think I said there wasn't.
Okay.
All I know is that I.
The one thing I got right on this.
All right, so let's keep going. Number 3 says Damien Walter has a mass of 74.8 kilograms. With that information, what is the minimum speed in meters per second in miles per hour he must have in order to be able to make the loop-de-loop? All right, so in order to do this, you're going to use your centripetal force equation, right? So the centripetal force is equal to mass times velocity squared over the radius. Okay. So let's see. Mass of the dude is 74.8. Okay. Let's see. The velocity squared is what I'm solving for. Okay. That's v squared over the radius. The radius was 1.5 meters. That was measured. Now the force, centripetal force, in this case, in this problem, what is the minimum speed? So what is the only force acting at the top of the loop? Force of gravity. So force of gravity is equal to the mass times acceleration due to gravity. Okay, so the mass of the dude is 74.8. The acceleration due to gravity is 9.8. So I need a calculator. Or does anybody have that? 74.8 times 9.8.
Yeah, no sir.
Okay, so I got the force to be 733.04. So 733.04. I'm just going to do 733. Now, solve for V, and that's how you would get that. Okay, so let's all solve for. You got an answer?
No, I did it differently, and I got the same answer.
Sweet.
I don't know what I did.
I'm intrigued, but I
mean, I wrote down I can't really read it, but I wrote it down. I just did 74.8 times 9.8, but my 74, the mass was out in front of the velocity of the loop.
so you got
And then I
mass.
just canceled out the 74.8 on both sides.
You can cancel the 74.8s on both sides.
So then I just got
So, yeah.
9.8 equals velocity over 1.5.
9.8 is equal to velocity squared over 1.5. Yeah, exactly. Okay, and then my velocity. Let's see, got a 2 sig fig, so 3.8. What I got? Tell you guys again. And that's how you'd solve for the minimum velocity. All right, and then conversion to miles per hour, but I don't feel like doing that. Does that kind of make sense how to solve that type of problem?
It's about
8.5 miles per hour, perfect. Okay. So that was number 3. Number 4 said, what is the percent error? Okay. So if you watch the second video, just do your actual minus experimental. Did you guys watch the second video of this? Yeah.
Oh, what did you use to measure it?
Measure what?
The person in the loop in the video?
A ruler.
Okay.
And do the conversion, because the guy was 1.8 meters tall.
Yeah, I got a bit more. These calipers.
Nice. Okay. Number 5 says, if Damien had no problem being able to run the medium the minimum speed. Why did he have such a hard time doing the loop-de-loop? So the minimum speed was we calculated
Commitment issues.
meters per second. However, in the video, he was able to run 7 something meters per second. Why did he have troubles?
Commitment issues.
It's like climbing stairs in a circle.
Exactly. All right. As you start to go up, you should start to slow down. All right. And when he got to the top, he wasn't going that 3.8 meters per second. That should be all the answers for the first video. Do you have any questions on that? Not too bad. Let's move to number 2 video. Number 2 video. The car.
This one was cool too. I like it.
Let's watch this guy real quick.
Things going in loops
I
is
like
just
to be
inherently
like
cool.
That's pretty much it.
Yeah.
Of course, when we go back into school,
The dude that fell off like completely.
The
off the
internet is
basketball, I was like,
today.
oh, it's just fun.
All right. So here's the car one.
it is so slanted.
It's just fuzzy.
What? My thing?
I think it's just kind of.
Just like,
Yeah, just slant your head. It works. I'm gonna fast forward a little bit if that's all right with you guys.
Okay, why do you not get all the cool upgrades? I feel like science teachers should have the right way.
Why
None
what?
of them do.
What cool upgrade would I get?
Like the smart boards.
Oh,
the new ones.
Huh? Oh, I know. Like my stats teacher got one, and I'm like, Mr. Bowers,
Yeah,
does he even get a regular one?
Like new, like.
I mean, he has more writing.
We're cool. We're good. I make do with what I got.
I mean, have you seen the amount
I
of
am
expo
only on my
markers?
second year in Springboro
That's
though.
true, but
Have you seen the amount of expo markers he has?
That's what I'm talking about. I'm proud of that.
you could trade all those in for a
It's just
smart
like
board.
give him all your.
There's no do-overs in that thing, though.
No, you either go all the way or you're not.
Like, you gotta commit.
That does look really fun. Like if you're driving on that line,
But what if you?
I could just keep going, keep going. That'd be okay.
I'm getting-
That looks like a normal car. It
That's
doesn't.
That's pretty cool.
That's the best part.
That is. I almost skipped it. Can't believe I almost did that. Okay, so let's answer these questions.
Let's go.
All right. So, let's see. Set up the video to be 0.25 speed and use your stopwatch to record how long Terry Grant in his car is in the loop-de-loop. Okay. I got close to 2.75 seconds.
I got 2.84 seconds.
If you got anywhere from 2.5 to 3, you're probably within the good range.
Let's go.
Okay. All right. I'm just saying what I got. Okay. Now, Terry breaks the record for the tallest loop-the-loop at 19.808 meters. That a car gets driven through. Using that knowledge, find the average speed Terry was driving the car through the loop-de-loop. Okay, and I gave you the equation, right? I gave you the equation. So velocity is equal to 2 pi r over time. Okay. So using that equation, let's see. So 2 pi. So my entire loop-de-loop was 19.08 meters, which means what's my radius? 9.54. Does that part make sense? Over whatever your time was. All right. My time that I got was 2.75. Okay. Your time was probably might have been a little different. Okay. Plug this in the calculator. Fine. One. Okay. I got around one sig fig. One sig fig will take me to 20 meters per second. Okay.
You guys all just said
Okay. Let's see. Draw a free body diagram of Terry at the top and bottom of the loop, then circle the point where he would experience the most normal force. Okay, now, this one's a little tricky. Okay. So, when he's in the car, he goes above the minimum speed. Okay. So when you draw it out, here's the loop-de-loop. Okay. Once again, at the bottom you have the force of gravity and the force normal. Right? However, if you look at the top of the loop-de-loop, at the top, you're still having the force of gravity, but you're also having force normal. All right, you're also going to have force normal, and force normal also goes down. Okay, so if you look, force of gravity, force normal, at the top, your force normal is actually going down, and force of gravity is going down. Okay, because he's going above the minimum speed. If he was going the minimum speed going on the loop, there would not be a force normal. Does that make sense? A little bit. What was your question, Taylor?
That's what I was going to ask.
Perfect.
Why is there force normal?
Yeah, so he's going above the minimum speed. Okay.
So if he was going below the minimum speed, he would just drop.
He would just drop.
There would be no do-overs.
Yeah.
It would
Yeah, just drop.
be a flat track.
And that's why the only force would be the force of gravity. Yep. And then it says, circle the point where you would experience the most normal force. It'd be at the bottom. All right. It's the only positive normal force. Cool. All right. Let's see. Terry has a mass of 82 kilograms. Using that knowledge, calculate the G-force Terry experiences at the top and the bottom of the loop. G-force is equal to how much the normal force someone experiences compared to the amount if they are standing still. All right. Example, if his normal force is twice the amount of from what it is, if he was standing still, he would experience 2 G's. Okay. So let's check this out. I'm gonna flip over. I'm gonna get a new piece of paper. All right. So at the top, we're gonna do the top first. My force normal is pointing down. So what's that mean? Negative force normal. My force of gravity is pointing down. What's that mean?
Minus.
That's what I did wrong. Okay.
Okay. So my sum of forces, and my acceleration is technically going down. When I'm at the top, my acceleration is going to go down, so I have a negative mass in there. Does that part make sense?
It doesn't.
Yes.
Okay.
That's what I did wrong.
All right, so let's see. I got to solve for normal force. Okay, so negative force minus, let's see, force of gravity is mass times acceleration due to gravity. So in this case, we're actually looking at gravity as gravity, so it's actually going to be our negative 9.8. Right? We're going back to the negative, good old actual gravity. Okay? And that's going to be equal to the mass. Oh, I'm going to zoom out a little bit. It's kind of a big problem. Is equal to the mass, which is 82. And then A, acceleration. Centripetal acceleration is velocity squared over r, correct?
Yes.
Okay, so my velocity squared. So velocity, let's see, where did I get that? My velocity is what I just solved for up top. We said 20. So 20 squared over r. And my radius is 9.54. Does it make sense where I got all those numbers?
Yeah.
Just making sure. Okay. When you solve for this, I got the forced normal. So I don't need sig figs yet, right? I don't need sig figs yet. I got my forced normal to be, let's see. Anybody get an answer? I haven't got it yet. 20 squared divided by 4. Okay, I got 279.
Well,
Did I do that wrong?
No, we probably did.
Yeah.
I did that completely wrong.
That was probably what we did wrong.
I got 4.
Okay.
I got 20.
No, you're good. You're good. That's forced normal. You're. Let me see.
You're gonna have us confused either way.
Let me plug it in. Why? All right, so I got around.
4,000.
No, you're good, guys. So my forced normal, which is this, my forced normal, I got around 3,200.
Oh my god.
Hey, right there.
Okay. Now to get the G force, it's compared to how much they would get standing still. Okay. So you got to take into factor how much they're going to get standing still. So force, mass times acceleration. So his mass is 82. So now that will give you the G force. That's when he's in the roller coaster. That's when he's standing still. Okay. So the G force should be around 4.
That's got my mind blown. Completely.
It's a little tricky. So the G-force here is about 4. And you do the exact same thing for the bottom. However, the bottom equation is force normal is positive, right? Force normal is positive, gravity is still negative. And my acceleration at the bottom is positive. So it's going to be mass times acceleration. Okay. So once again, it's very similar, all right? So force normal. Once again, this is my 82 times negative 9.8. Okay. Okay. And then that's equal to the mass times acceleration. Okay. And here I got around 6 G's on this one. How are you guys? That close to what you guys got?
5.3.
5.3. Yep.
Negative.
No. I think you switched your twos up.
Yeah.
This is the bottom.
No. That's what. I
It's a
just.
little off.
I was really off on this.
I put mine in Newton's.
Well, I mean, it looks like you have like very similar answers to what we got.
Mr. Bowers,
The one that we had at the top.
I did wrong.
can you
I did.
go back to the top equation real quick?
I think you might have just switched them
I
up.
should have
Thank
done negative force normal minus the force of
Or is
gravity.
that Tommy saying that? Is
The
that Tommy?
negative mass times acceleration. I didn't.
You guys
do the
kinda sound
negative
similar.
I think you switched them up. I think you just put the bottom one on the top and the top one on the bottom.
Sort of.
So those are basically the same answers we got, but.
And then number 5 says, it was recorded that Terry in his car experienced 6.5 G's at the lowest point. All right. What is the reason why your calculations are most likely lower? Why would our calculation be lower? What did we do?
Found the velocity.
Oh, you're missing one word. You're super close. You found the average. The average velocity, right? We didn't find it at the lowest point. We found the velocity on the average velocity throughout the entire loop. All right. So the lowest point is going to be a little bit faster. The highest point is going to be a little bit slower.
It didn't look like he slowed down in the video. I know he probably did, but.
Maybe just by the tiniest bit.
Your the car is pretty heavy.
All right, we're almost done actually. What time? Oh, 5 minutes.
Dude, the kid in the next video made me very mad. The one who kept on like going out of pose. I was like, get in pose, kid.
Oh, I was annoyed with the.
You watched
The
the
rotor's
video?
gonna take
No,
it.
I didn't watch the video. I knew it.
All right, can I move on? We
It
good?
didn't look like they were going that fast.
All right.
And then he like.
So the next video, we should be able to watch it, maybe even answer the question.
Okay, now.
Yeah.
Wait, which kid? The one on the right or?
He doesn't spread his legs when you're
This
supposed
kid?
to spread your legs. Yeah, and he falls off.
And he's the one that falls. He's the one that ended the ride for everyone.
He looks like a mini version of the kid on the right. Like, they look, they're definitely related.
He looks like he eats crayons.
And the dad starts yelling. He goes, "Spread your." Yeah, he goes, "Legs apart." He doesn't listen.
I work with kids for a living. They don't listen.
That's true.
They listen.
That looks super fun, actually.
He also clenches his
How many
hands.
kids do you teach in a class? Four.
So if you just like jump
That girl's awesome. She's like, yeah.
Like how?
That other guy,
Yeah.
what is he doing?
Why is he just pointing?
He looks like he's from Stuart Little. The kid with the glasses looks like.
Who is that thing?
No, don't do it.
He looks like Spider-Man.
They're all.
I really want to go do
Off the
that.
wall and see what.
What if somebody would
Actually, I would probably.
never not do
And he's the last one to fall because he's so freaking.
All right. So let's see. Watch the whole video and observe the orientation. The rotor spins faster and faster as it slows. All right. Draw a free body diagram is what this one said. And this is the last one I'm going to go over. We'll go over 4 tomorrow. Draw a free body diagram. It explains the physics behind how the. Oh, this might take a minute. We watched the video. I'll go over it tomorrow. How about that?
Okay.
We'll draw free body diagrams, and then we'll watch number 4 tomorrow. Then we'll get into some angular angles. We'll talk about this angle. 5 letters. 5 letters is enough. And then we'll get to the easy part of the chapter.
I thought that was.
No, that's the medium part. We'll get to the easy stuff.
Well, I don't know.
Easy stuff. Let's see, is it even on here?
Oh
my God. Oh my God.
Everybody. You know, it's just. I'm surprised.
All right, we actually might be adding one to this equation sheet. All right, guys, have a fantastic day. Good job today.
Is that your water bottle?
Yeah. Do we have anything to do on Friday?
Students,
Hopefully
as
this will
you're
make a little bit more
going
sense.
through your next period class,
See you, Mr. Bowers.
go through your homeroom one more time. If you did not get your report card, once again, go through your homeroom teacher's classroom to get your report card if you did not get it during the last bell